What's going on, guys?
What's going on here? We're going to do some linear programming. All right, so what they've done is they have graphed this figure. They've given me this equation, which is my cost equation. And what we're going to do is each of these ordered pairs here that are the vertices, we're going to plug them into this cost equation and figure out which ordered pair will maximize and minimize the cost. Okay, so on my paper here, I'm going to copy my cost equation. And then I'm going to make a list of my ordered pairs. They are 0, 56, 30, 30, 40, 0, and 0, 0. Okay? And I want to evaluate each of those ordered pairs using that cost equation. So, at 0, 56, x is 0, y is 56. So my cost is going to be negative 56. And I say that's a cost equation because it's a C. That doesn't make sense, but because cost can't be a negative amount. So maybe the C represents something else. But for the ordered pair 30, 30, plug those in, I get 30 minus 30 is 0. For 40, 0, that's 40 minus 0 gives me 40. And for the ordered pair 0, 0, that is 0. And then down at the bottom of that sheet, it says, let me zoom out just a little bit here. It says the minimum is blank. So what is the minimum amount I got over here? Negative 56. And then it says when let's try again. When x equals what did I get that negative 56? 0, and y equaled 56. Then they want to know the maximum. So the maximum amount I got when I evaluated that function was 40. And that happened when x equaled 40 and y equaled 0. And that's all you're doing for those four on the left-hand side of that page. Okay. Then, for numbers 5, 6, and 7 on that page, what you have to do is you have to graph these, inequalities that they give us here. Graph those, and I would use graph paper. I would not try to do it here. Graph those, and then figure out what the corners of that figure are, what your vertices are, and do the same thing. So do y'all want to pick one, either 5, 6, or 7, and we'll do it together? Do 7. All right. For number 7, let me get my x and y axis drawn here first. All right, if I'm going to graph x is greater than or equal to 0, isn't that going to be a vertical line? And which way will it shade if it's greater than that? Greater than 0 is going to be right or left? Right. So far I am shading, over here. Okay, and I'm not going to shade it too dark because I've got several other things I have to shade on here as well. Okay, so I am to the right side over there. And then I have x is less than or equal to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be another vertical line, but less than is going to be to the left of that. So right now, all of my overlapping shading will be here in the middle, okay? Y is less than or equal to 10, so that's going to be a horizontal line. And less than is going to make it shade underneath there. I'm going to get rid of some of the extra here. And then the last equation they give me, I'm going to have to work on for a second. They give me 2x plus 3y is greater than or equal to 24. You've got to get that in slope-intercept form so you can graph it. Okay, so there's my slope-intercept form. I'm going to go to 8 on the y-axis, and from there go down 2 and over 3. And it says that it is greater than or equal to. So it's going to be on top of there. So where all of my overlapping stuff is, it is inside this figure. So what we need to do is we need to figure out what those vertices are. Okay, this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. And then I have 9, what is that, 9, 10? And that one is 0, 10, and this one is 0, 8. So you will take the objective function, whether it's cost or whatever that they gave us, and you're going to evaluate it for those 4 ordered pairs. Y'all need me to help you finish from there? Okay, then we're going to stop at that one.